All right, so we're back. We're just kind of chunking these through as we go along.
So we're on number 10.
Yeah, number 10. Number 10 asks you to give examples of a process that involves physical changes. So you need to know the difference between a physical change, changes in size, shape, state, things like that, compared to a chemical change, which produces something new and unique and different.
Right. And I think we gave them in our videos, we gave them several examples of physical changes when we were talking about the methods of separation.
Yeah.
We also looked at how we can separate things that are physically bonded, so we kind of tied all that into some examples of physical change. And you have to ask yourself, when you read the answer choices to this, and you think about each process being mentioned, does that process really change the material at the atomic molecular level? For instance, melting an ice cube. Melting an ice cube takes cold water, that is, particles are attracted, and makes it a little warmer, and the particles get jumbled up a little bit, and they separate from each other a little bit.
But it's still water.
It is still water.
So.
But if you leave like an apple out to rot for, I don't know, a week or so, when those bees, they're not bees, but they're wasps.
Oh,
they start,
they show up,
they eat it all again.
Right. So digesting that apple.
Mm-hmm. That is a chemical change. So that we're changing the chemical compounds within that apple into other things.
Yes.
Burning wood would be something similar.
Right.
Number 11. Give examples of mixtures as opposed to elements and compounds. Now, this is one of those that is which of the following is not or cannot be classified as either a pure substance or a mixture. And you need to remember, I think as a clue for this one, that pure substances are both elements and compounds.
Right.
Okay?
Right.
And mixtures are things just mixed, stirred together.
Physically next to each other.
The iron and sulfur before you put them, before you start heating. That is metal shot.
So is that zinc and
aluminum
and lead. You can't see it in there. I don't know, maybe you can. There's some big puffy pieces of zinc, and then there's some little tiny pieces of lead, and that's a mixture of two pure substances. You have the pure aluminum and the pure lead. They're in the same container with each other. Mixture.
Right.
Right.
And here we have some silicon dioxide.
That's sand.
Yeah. Well, we have silicon dioxide holding it also, as a matter of fact. Melted silicon dioxide.
I have a headache now.
And this is pretty uniform, but if we look really, really closely, there are some other specks of stuff in there that would make that a mixture. If we wanted to take our tweezers and our magnifying glasses, we could pick that apart.
Yes.
All right, let's move on. Number
12. Number 12 says define heterogeneous and homogeneous mixtures. How do you tell them apart? What's heterogeneous? What's homogeneous? Homogeneous is uniform throughout. Everything is evenly distributed. That's a copper sulfate solution, and it's the same everywhere. The first sip will kill you just the same as the last sip will kill you.
It looks like that blue raspberry Kool-Aid, but it is not.
It is not. A marshmallow is actually a mixture. It's air and sugar, isn't it?
Yeah.
Is that homogeneous or heterogeneous? Well, whatever it is, it's delicious. And now I'm sidetracked.
Right. And then going back to the mixture that Mr. Sustin had a second ago, this is a heterogeneous mixture. Our favorite example is the tossed salad, where we can see all the different pieces, parts of stuff. That is a heterogeneous mixture.
Where each piece keeps its own identity. Like, well, going back to the lab that we did the other day, when we had the iron mixed in with the little flakes of, did I just say the iron? Sulfur flakes. Mixed in with the iron, and you pass the magnet underneath, and all the iron still was magnetic, and all the sulfur still was not. And so each part keeps its own properties in a heterogeneous mixture.
Right, that sounds like a phase also, because I know that question is coming up.
Mm-hmm.
All righty,
13.
number 13. What do you know? Identify the types of substances that exist in more than one phase.
Yes.
More than one phase would be an example of a heterogeneous mixture where you can see, phases are like parts, where you can see one part distinctly from another part.
Right.
Okay, number 14.
14, give examples of heterogeneous, homogeneous mixtures.
So there's a lot of questions
Yeah,
right in a row
yeah.
to kind of differentiate those. So,
And that was 14. This might be, you know, from this list, identify the one that is homogeneous.
and
Or
there'll be
something.
substances that
Yeah.
you've experienced in your everyday life.
Right.
Okay, number 15, define or describe the process of distillation.
Yes.
Okay, we did a filtration way back in the first lab. That was a method of separation for solids. A distillation is another method of separation for mixtures that are liquids.
Right.
And like when we distill water, we actually heat it and boil the water off and collect any solid or debris or contaminants in another container to purify the substance.
Right.
To start with a mixture and end up with a purified substance.
Right.
Okay.
16. Compare a compound and a mixture. Similarities between the two and differences between the two. What's the big difference between a compound and a mixture? I personally focused with my kids
Yeah.
on the fact that compounds have one composition. There's
Yes.
one way to put them together.
Right.
And in mixtures, you can vary that kind of any way you want. You can have very, very sweet iced tea or unsweetened tea. It's still, you're still going to take a sip and go, hey, that's iced tea.
So we did this in the iron and sulfur lab too. Part of that lab, you stirred together any amount of iron and sulfur you needed just to make a quick mixture. And in the other part, we measured very specific amounts of iron and very specific amounts of sulfur, the right stoichiometric ratio, the right recipe to cause those two substances to react completely